median, and mode. The 3 M's, they are all measures of the center of a set of data points, and they all measure the center a little bit differently. The first one, the mean, is often referred to as the average. This is probably the one that you do the most often. I'm sure every one of you has calculated an average before. I'm going to give us a set of numbers for us to look at while I go through these definitions. Let's take these random numbers. 3, 5, 7, 9, and 9. So if I were to find the mean, aka the average of these numbers, I would want to add all of them together and divide by however many of them I have, the total number of data values. So in this case, I have 5. I would add all of those together. The mean of this set of data would be about 6.6. The next measure of center is called the median. I like to think of the median as like the middle. Like if you have started your driver's ed, maybe you know that the median in a road is like the thing that divides the two different parts, like the two different directions on the road. So that's what I think about. I think about it being in the exact middle of something. So to find the median, it is important that we have arranged the values in order from least to greatest. And then we literally find the exact one that's in the middle. So if I have, again, my data points, 3, 5, 7, 9, and 9, the one that's directly in the middle of them would be a 7. There's a little note here that says what happens if we have an even number of data points and we end up with 2 numbers in the middle. We just are going to take the average of the 2 numbers that are in the middle. So again, you do the mean formula. We would add them and divide by 2. So that's what happens if it's even. That's just kind of a little side note in case that does happen, which it happens pretty often. The next measure of center, and the last of our 3 M words, is the mode. The mode is the one that occurs the most times. So if I have my data set 3, 5, 7, 9, and 9, obviously 9 appears twice in that set of data, so it would be the mode. Sometimes we have no mode. Sometimes nothing repeats. Sometimes it's just 1, like in this case, we have just the 9 is our mode, and sometimes data points repeat the same amount as other data points. So if there was 2 5s in here as well as 2 9s, my modes would be 5 and 9. Okay? So that's mean, median, and mode. Any questions on those 3 terms? A couple other ones we're going to talk about are outliers. They are values that are much greater or much less than other values in the set. So for example, if I had my data set 3, 5, 7, 9, and 9, and I added in a point that was like 28, 28 would obviously be way higher than the rest of those numbers. We would consider that an outlier. And then the last one here is the range. The range represents the difference, so subtraction, between the greatest and the least data points. So in this set of numbers, I would do 9 minus 3, and our range is 6. The higher our range is, the more spread apart our data points are. The smaller our range is, the more consistent our data points are. Any questions on those definitions? All right, so we're going to look at some bowling scores. There are 8 people bowling in this game of bowling. Their scores are they're mediocre at best. We're going to determine all of these different things. The very first thing that I want you to do when we look at a set of data is to rearrange them from least to greatest. It's going to help us figure out all of these different things. So I'm going to go ahead and start with what's the smallest number, 104. And I'm going to keep going. The next smallest is also 104. The next smallest is also 104. Oops. Then 109. And then 113. Then 117. 136. And the largest one is 189. Everybody got it from least to greatest? Okay. I'm going to refer to my definitions to help me out here. The first one is the range, the difference between the greatest and least. So the greatest is 189. The least is 104. I'm going to subtract those two numbers to get that the range in my set of data is 85. The next is the mean. The mean is our word for average. So we're going to add all those numbers together and divide by however many data points we have. So I'm going to start by adding every single one together. I think I can fit them all in there. And then I'm going to divide. There are 8 total data points in this set of data, so I'm going to divide by 8. When I add all those numbers together in my calculator and then divide by 8, I get 122. The next measure that we're going to use is the median. So this is the real reason that I arranged my data from least to greatest, is to find the median value. So to find the median, we're looking for what's in the exact middle. Here's how we're going to do it. I'm going to look at all my data points. I'm going to go from the outside and work my way in. Okay, so cross off one lower, cross off one higher. I'm left with 2 in the middle. This happens sometimes when we have an even number of data points. In order to find what's in the exact middle of these 2 data points, I'm going to average them out. What's in the middle of 109 and 113? Beautiful. So our median here is 111. Any questions on that? The last one is mode. Mode is the one that occurs the most frequently. Hopefully we can tell what's the mode in this data set. Beautiful. It appears 3 times, so 104 is the mode. Okay, so now we have to look at what is best. Out of mean, median, and mode, which one do you think best represents what the central tendency of our scores is? There's no right or wrong answer here, just what do you think is the best? Any ideas? James? Why do you think the median is the best? Because it's kind of in the center. Why would we say maybe the mean isn't the best here? Why isn't that 122 super accurate? Anybody? Yeah, Sarah? Yeah, because of this outlier that we had, this 189, we have one bowler who's really, really good, right? They bowled, well, not really, really good, 189. They bowled a 189, which kind of skews our data a little bit higher, okay? So we could say, I would say that the median is best, just like what James said. I would say the median is best because the outlier, we're going to use this word skews the mean to appear higher. Okay? Only really 2 of our bowlers bowled higher than a 122. So if I said that the average was a 122, I'd kind of be giving them a little bit more credit than they deserve, all those 104s down there. So I'm going to go with the median. Okay, now let's take that same set of data and let's exclude the outlier. We're going to see what changes when I don't use that outlier. So the same data points, but I'm not using that 189. First of all, let's take a look at my range. I'm going to take the greatest value and subtract the smallest value. 136 minus 104 gets me 32. We should notice that that range is much tighter than it was when we had that outlier. That's a good thing. That means our scores are more consistent. Okay, if our range is greater, remember that means we're a little bit more spread out. Let's find that mean. I'm going to add all my scores together. 104 plus 104 plus 104. Plus 109, plus 113, plus 117, plus 136. I got rid of that outlier, so now I'm only looking at 7 of the scores. So my mean value, about 112.4. To find the median, we got to make sure that they're in order, which I already did. They're in order. So I'm going to cross out one lower and one higher until I get to the middle. That median is 109. The mode, did the mode change here? Nah, it's still 104. And then what do you think? I would say the mean is probably the best now. It's not skewed, so it's pretty dead on. When the mean and the median, when these two are close to each other, that means our average is going to be pretty good. So I'm going to say the mean because it is close to the median. Any questions on these? We feel like we kind of got a hang of it. We're going to do a little bit of application now. So let's turn it over. Okay, so imagine you're trying to invest some money in some stocks. There's 2 different stocks for you to choose from. You are going to look at the stocks for the first, their sell price or whatever, for the first 5 days in February, stock A and stock B. We're going to figure out, if you're an investor, which one would you rather invest in? Again, we're kind of up to interpretation here, so we'll see how it goes. Let's first find the range of each one of these stocks. In order to do this, I really recommend you reorder these. I like to do that first anytime I look at a problem. So I'm going to put these in order from least to greatest. Just helps me a little bit. 28. 31, 31, 34, 36. So now to find the range, we take the greatest number and we subtract the smallest number. Oops. Sure. That's awful. Hello, erase. There we go. So 47 minus 25, this range here is 22. Oops. Oh, God, okay. There we go. And then 36 minus 28, this range is 8. And then let's find their means. Remember, mean is average, so we're going to add all their pieces together. We tracked this over 5 days, so there's 5 data points. The mean value for stock A is going to end up being 32. And then let's do the same thing for stock B. And this one's going to end up also being 32. Okay, so I bet put yourself in the mind of the investor. The average is the same. They're about the same sell price. Which one do you want to put your money into? There's not really a right or wrong answer. Jaden, what do you think? Okay, so this is not fluctuating. We say it's more consistent. Okay, so that's less risky. What if you're like, I want to go all out. I want to be aggressive. I want to see if I can make the most money possible. Then what are we picking? Then we'll probably pick stock A, right? Because if we want to make money, we want something that's going to have highs and lows. So maybe you want to be more aggressive. It fluctuates more. It's more risky. Kind of depends on what kind of investor you are, I guess. Any questions on that one? Okay. The next 2 problems here are super common problems. You're definitely going to see these on your homework. You've definitely asked me to do this for you, so it's good that we're doing this together. This is where we calculate. You have 3 exams that you've taken so far. You want to know what grade on your 4th exam do you need to get an average of 90? How do you get an A average? So here's how we do that. We know we're finding an average. So we're going to set up our formula to find the average, which is we take all of the values, we divide them by however many tests there are, and we want it to equal an average of 90. So that looks like, if I can write, 80 plus 93 plus 91. Those are your first three tests. Do we know what we're getting on the fourth test yet? No. So instead of putting a value, I'm going to put a variable because I don't know what I want that to be yet. There's a total of 4 tests that we are taking, and I want that average to equal 90. We're aiming for an A. So now we're going to solve. I cannot touch this thing in the top yet. 80 plus 93 plus 91 plus X. So I have to multiply by 4 first before I do anything else. 80 plus 93 plus 91 plus X equals 360. I can combine my like terms now to be 264 plus X equals 360. And then subtract 264 from both sides to get that the grade that I need to get a 90 overall is a 96. Any questions on that? Okay. Somebody was like, oh, I don't think I can get a 96, so maybe an A isn't achievable for me. What about a B plus? So they're saying use the same grades, the same 3 grades. I don't think I can get an A. Let's aim for an 88 instead. Can somebody help me set this problem up? Same problem, except we're getting an 88 instead of a 90 now. What's my setup look like?
Same setup as the last problem, so it's 80 plus 93 plus 91 plus X over 4.
Okay, and it equals?
88.
88, perfect. So solve the same way. We're going to multiply by 4. This equals 352. Combine my like terms, 264 plus X equals 352. I'm going to subtract that from both sides to get that X equals 88. So in order to get my average to be an 88, I just need to get an 88. Not too shabby, not too shabby. Any questions on this? Okay, one last topic. This is a little bit different, so we have to do it. The last topic for this section is called dot plot. Okay, that's a new vocab word for us. A dot plot shows the number of students in each homeroom at this high school. So every X in this diagram represents a class of students or a homeroom of students. So maybe make yourself a note. Each X represents a class. So that means, if I take a look at maybe the first column, that means 4 classes have 19 students in them. Okay? So we're going to figure out mean, median, mode, and range for each one of these. The mean value, okay? The mean is the average of all the different classes. I can count these X's. How many different classes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20 classes in total. So to find the mean, am I going to sit there and write 20 things into my calculator? Probably not. That's a lot of things. So what's nice about dot plots is that it kind of organizes it for us. So I can say, instead of adding 19 plus 19 plus 19 plus 19, I know that there are 4 classes that have 19 students. Is everybody following? There are 5 classes that have 20 students. There are 6 with 21 students. There are 2 classes with 22 students. 2 classes with 23 students. And then there is 1 class with 24 students. Much easier to type into my calculator, I think. There's 20 total classes, so I do my mean, my average, just like that in my calculator. I'm going to end up with 20.8. Any questions on that? Okay, median. Median is the middle, like the middle of the road, remember? So I'm going to look at my data points. Just like we did when they were in order, I'm going to cross off one from the bottom and one from the top. And we're going to keep going until we figure out what the middle is. Oops, I don't know why I did it like that. Oops, I think it should actually be, there's two of them. So I get two of these in the middle, an X and an X in the middle. I cross off one low, one high until I get to the very middle. Any questions on how I got those? So the median value here is 21. Two more. What's the mode in this set of data? 21, the most frequently occurring. And then the range, I go from the highest to the lowest. I subtract them, my range is 5, pretty consistent. And then what do we think? How do we know whether the mean and the median are equal based on just looking at this? How would I know? Look at our mean. Our mean is a little bit lower than our median. Why do we think that is? Just based on the shape of that dot plot. Here, let me erase some of my dots. Why, based on the shape of my dot plot, would I know that my average was a little bit lower? Any ideas? They're what? Any ideas? We're going to talk about this a little bit more on Monday, but the idea is that if my dot plot is more symmetrical, those numbers should pretty much be the same. Do you see how my dot plot has a little bit more on this left side, on this lower side? So because there's more dots on the lower side, our mean is a little bit lower than our median. So if the dot plot was symmetrical, median and mean would be the same. Any questions on that?